Alright, so as we move on through our hydrocarbon slides, we've got our branched chain alkanes that are next. So branched chains and other hydrocarbons, they don't always have carbon atoms bonded in straight chains. Because a carbon atom has 4 covalent bonds, it can bond to many other carbon atoms that create branched chains to them. And there's all kinds of different ways that these can be drawn and named, and that's really what the focus of this video is on, is how to see these alkane compounds, how they can be drawn and how they can be named. So an atom or a group of atoms that can take the place of a hydrogen atom on a parent hydrocarbon molecule, they're called substituents. That's a fairly key word. It's something that I would certainly understand and know what substituent means. So a substituent really just means a branch that's coming off of a parent chain. To understand what a parent chain is, well, that's the next part. The parent alkane in a hydrocarbon, the parent chain is the longest continuous chain of carbons. Not necessarily in a straight line, they could go all over the place, but it is the longest continuous chain. So almost if you took your pencil and just kind of started drawing a line through your carbons, it's the one that will contain the most carbons in it without tracing back or skipping over anything. So the longest continuous chain of carbon. So a couple of here, there's a couple questions here. Which is the parent alkane? What is the name of the parent alkane? And then which is the substituent? So if you could take a guess on each one before I get started, just pause, take a look at them, see if you can identify which is the parent, what is the name of the parent alkane, and then which is the substituent. Alright, so if I take a look at the first one, we can count the longest chain here. While my longest chain looks like it could be here, it could be 3 carbons in a line. It could also go like this. It's the longest chain in the line because there's 3 carbons there. And it could also go like that. It's the longest chain in the line. So the way that this one is drawn actually gives me a couple of different options here on how I can go through and find out what the longest chain is. Whenever this happens for me, I like to keep it simple and just go straight across. So which is the parent chain? I would say I have my parent chain there. What is the name of the parent alkane? Well, this one has 3 carbons. So if I take a look for 3 carbons, I can see that from either the table in the back or looking in your book or your notes from before, 3 gives me propane. And which is the substituent? Well, if this is my parent chain, then my branch or my substituent is right here. Likewise, if I would have written my branch or my parent chain, I should just kind of note this, that if this would have been my parent chain, then this becomes my substituent. It's the branch that comes off of it. So it just depends on how you see these and how you kind of identify them throughout. So if I take a look at the second one and try to identify its longest chain, well, I can see right away that my longest one on the bottom here is 6. So can I make one longer than 6? If I go kind of straight down from the top branch, so we see I have like 1 and then into 2, 3, 4, 5, so that doesn't do anything for me. If I start on the top here again and maybe do 1, 2, 3, 4, 5, 6, so there's a 6, the same as my bottom line. So I've kind of got a tie there, so that doesn't really change much. And then as I start to move in from there, really I only end up getting 5s. 1, 2, 3, 4, 5 is my longest one after that. So it looks like 6 is the most carbons I can get in a continuous chain in here. And again, when there's 2 of them or more, I just pick the straight line. It's the easiest way to go. So the name of this one, I've got 6. 6 matches up with hexane. And I've also got a couple of branches as well here, or which is the substituent. So my substituent here, there's actually more than one. All 3 of them are branches coming off of that parent chain. And so the next question becomes, well, how do we go through and name those? So a hydrocarbon substituent, they're called alkyl groups. They have this YL ending. The same prefix stuff where we start talking about alkanes just has that YL. So an alkyl group can be 1 carbon, or they could even be several carbons long. They're just not part of the parent chain. They're named by removing that ane at the end. So picture writing out methane, right, our branch. So named by removing the ane. So that means that this part is gone. And then it says adding a YL in. So that just becomes like this. It becomes methyl instead of methane, which we can kind of see down here. And ethane would become ethyl. Anybody take a guess maybe what propane might be? If you want to say it out loud, just see if it makes sense. Well, you get prop instead of ane. I got ill, so propyl. So an alkane with one or more alkyl groups, they're called branch chain alkanes. The name of the branch chain alkane is based on the name of the longest continuous carbon chain. So that's how it's named, but then there's all kinds of little rules, little things that we have to take into consideration. So let's start to get into some of these. This is something, again, it's just kind of an example going through, but I do encourage that you're jotting stuff down along the way, making notes in whichever way is going to help you learn best to go through and just kind of understand how these chains work. So IUPAC rules for naming branch chain alkanes. IUPAC is just the International Union of Pure and Applied Chemistry, so it's like the metric system. It's a standard system that everybody uses that deals with chemistry in a chem society. So we have this question that's here, this example of a compound. We need to figure out how to go through and how to name this thing. So first, we need to find the longest chain of carbons. So if I were to take a look up here at this picture, it makes our parent structure. So in this case, our longest carbon chain looks like it's going to go straight across. So if I started looking at this, I'd have 1, 2, 3, 4, 5, 6, 7 straight across. But can I make that any different? What if I stopped this one short here and went down instead? I'd have 1, 2, 3, 4, 5, 6. Well, 7's still my longest. Okay, and if I went over and then down, I'd have 1, 2, 3, 4, 5, 6. And then if I kept going, it's not going to change anything because I would continually have 7 here, or 7 is my longest chain. So that's why you see the bottom part highlighted along the way being our longest chain along the top, just because it gives me 7 as my longest chain so far. And so if you were to take a look at what our longest chain is, 7 matches up with heptane. So I'm dealing with a heptane structure here. We just need to figure out what everything else means. Specifically, what to do with the rest of these guys, all of the branches that are there. So, number 2, number the carbons in the main chain sequence. Start at the end. That will give the groups attached to the chain the smallest sequence possible. So in this case, we have, notice the numbers on the top that are all going, and they're numbered from right to left. And the reason why they're numbered from right to left is because I hit my first branch sooner going from right to left than I do going from left to right. If I were to number these off from left to right and go this way, the problem I run into is I don't hit my first branch until the 4th one. And part of rule number 2 is to start at the end. That will give the groups attached the smallest sequence. So I hit branch 2 first, so I'm actually counting from right to left and going through and naming these things. So I've got my values here going from right to left. Next, add the numbers from step 2 to the names of the substituent groups. So notice that in my first one here going from right to left, I have a methyl group. It's a single carbon, and it happens at 2. So that's the reason why I have 2 methyl written down. Same thing with the next one. I have a methyl group. It's happening at the 3rd carbon off the parent chain, so 3 methyl. Then I have 2 carbons here. It's not a methyl group anymore, it's an ethyl group. And this is happening at the 4th carbon. So that's the reason why this says 4-ethyl. So start to figure out where those are. Add numbers from step 2, where we identified our longest parent chain, into our branch chains. Use prefixes to indicate the appearance of the same group more than once in the structure. So there's common prefixes that we use here, and there's really nothing new here. Di, tri, tetra, penta, right? All the same kind of prefixes that you would have seen maybe in other things from before. So if we take a look from before, we actually had two here that were the same, right? We had two methyl groups. It's just they're at different numbers. So this example, we've got two methyl substituent groups. So we're going to say dimethyl as part of the complete name. So this dimethyl allows us to not write 2-methyl, 3-methyl, or sorry, yeah, 2-methyl, 3-methyl. We can combine them together. So we list the names of the alkyl groups, the alkyl substituents, in alphabetical order, but there's kind of a big caveat here that we don't use the prefixes for them. So if I have something that is a methyl group, I'm counting the M to go in alphabetical order. If I have dimethyl, I'm still looking at the M because I don't count the prefix. I don't count how many there are, just the naming of it. So an ethyl group would come before a methyl group. A butyl group would come before my ethyl group, and which will come before my methyl group. Doesn't matter how many there are in that parent chain, I just need to name them appropriately. So 4-ethyl gets listed before 2-methyl and 3-methyl. Now the methyl groups, we said we were going to call those dimethyl, but I just need to say where they're coming from in that parent chain from our question. So the numbers stay, but I can combine the two methyls together. So in this case, we get 2,3-dimethyl in the name. Now notice when I go through this alphabetically, the 2, the 3, and the di part, they don't have anything to do with where this is going to show up in the name because it's all based on the group itself. So it's an M for alphabetical order. So number 6, use proper punctuation, and these are very specific. Again, IUPAC rules. It's kind of in grade 11 you'll start seeing APA and MLA formatting for different things, and so this is no different in terms of kind of formality and where things need to be. So commas separate numbers, hyphens, they separate numbers and words, and there's no spaces in the name as you start to write it out. So you shouldn't have these huge gaps in between your phrases. So as I start listing these out, I've got my original question, and hopefully you can take a guess at what this is. If not, pause it, take a look at it, see if you can come up with an idea of what you think this might be, and then I'll show you the answer for it. So we knew that we were coming from here and going this way, and I knew that at 2 and at 3 I had a methyl group, and then I knew at 4 we had an ethyl group. So my ethyl group is going to get written down first, and then my 2,3 dimethyl group would be coming second because of alphabetical order, and then after that I would just have my parent chain written out. So hopefully you got to the value or the idea that said 4-ethyl, 2,3 dimethyl, and then the name of the parent chain as heptane. So let's go through and just kind of practice this a little bit just to see. So name this compound using that IUPAC system. Notice that the longest chain is not written here in a straight line. Take a second, see if you can figure out what this name is, pause the video, and come back when you're ready. So if you were looking here for the longest straight line, we've got 4 going across here. If I go down, I've got 1, 2, 3, 4, 5, so maybe you said 5 would work. If I start to look at the longest chain, remember, it just means there's no break. So starting off this carbon, I'd have 1, 2, 3, 4, 5. This one actually gives me 6. That actually looks like it's going to be my longest chain because any other way I look at it, I don't get anything equal to or bigger than 6. So if this were my longest chain, 6, I know I'm going to have hexane. And then what does this branch look like? Well, this branch has a methyl group and a methyl group. Now they're both at 3. So it doesn't mean I can't just write 1 3, I have to write both 3s because I have to say where they are. But remember the methyl, because there's 2 of them, becomes dimethyl. So 3,3 dimethyl hexane becomes my answer. And the last one, the compound 2,2,4-trimethylpentane, it's commonly called isooctane, it's found in gasoline. Draw a complete structural formula for isooctane. So again, pause the video, see if you can't sketch out what this looks like, and I'll show you kind of what I have here. Alright, so trimethylpentane. Start with your longest carbon chain, in this case, pentane. So pentane, back in here, pentane is going to give me 5 carbons long. So I know I've got a chain here that's 5 carbons. After that, this is trimethyl. So I know I have 3 methyl groups, and they're happening at 2, 2, and 4. So whichever way you start counting your carbon chain out, somewhere at 2, 2, and 4, I'm expecting to see it. So I counted my longest carbon chain going from left to right. And then at 2, and 2, and 4, I have my methyl groups. Now you may have flipped this backwards and may have written it so you counted from right to left, and as long as you still have from right to left 2, 2, and 4, you're completely right. Likewise, you might have, when you drew this out, might have put this methyl group, instead of on the bottom, maybe you put it on the top, like this. That's also completely correct. As long as you're following the patterns for it, the orientation of it can be drawn a couple of different ways. So just be careful when you're drawing them out that you're following the name that's present. And if you have any questions, just to let me know. And I think now we're ready to kind of move on with kind of a little bit of practice on your part. So take a look at the activity section on the website. It gives you a little bit of indication. I would like for you to read the careers and chemistry sections on page 701, and then there's a few questions for you to work on after that.